And that is how fast it is to boot. I am DJ Ware. On this episode of the Cyber Gizmo, I'd like to spend a few moments and go look at Clear Linux. This is an Intel distribution. A lot of people, I have seen a lot of comments from different Reddit users and some other comments that I've seen on the channel to the videos I did back in 2022 saying, oh, it's dead. No, it's not dead. It's not dead. It's alive. It's still being supported. In fact, the latest updates has all of the latest packages updates in it, including GNOME, including KDE, and including XFCE updates. So yeah, it also, the kernel is updated to 6.14. So yeah, I'd say that's pretty recent. And then no, it's not dead. They're still working on it. I don't think it quite has the broad focus of a lot of people working on it, though. I mean, one time they were, seriously, I'm not kidding, they were actually doing updates 9 times a day. I think that's probably a little excessive, don't you think? But, based on where things were in the early stages, I think a lot of that was just trying to get caught up, right? To make sure that the system had enough functionality. Clear Linux has been, gosh, it goes way back. I think 2008 is when Intel first started organizing a team to put this together. Their goal was not to create a general purpose distribution, but rather one that would be useful for IT professionals, for DevOps and people working in AI or cloud computing, containers, virtual machines, Kubernetes, all of those things. It was really designed for that. In fact, there was some talk for a while that they were going to abandon the desktop and just simply concentrate on the server and cloud versions. That was 2022. It has not happened. They are still updating the desktop version, and that's what we're going to look at today. So we talked a little bit about what it is. Let's talk about what it does. So Clear Linux is designed for speed. It's designed from the ground up to be fast. Now, granted, there hasn't been any benchmarks of this since 2022. I did one, ONNX did one, and we came out fairly close, but I think the telling thing is that at the time in 2022, I think it was in probably around the same time, around April, when I looked at it, it was blowing away the competition. There was just nothing that was close to it. So what did they do? What did they do to help this out? So, it is highly tuned for Intel x86 platforms. I mean, yeah, it'll run okay. Back in 2022, I said, yeah, it should run okay on AMD. No, in 2025, not only does it run okay, it runs great on AMD, and you'll see that today. All aspects of the system are optimized. They don't just, optimize the compiler flags and call it a day and recompile everything. No. They started with the operating kernel, and they worked their way down, balancing between hardware and software. Sometimes they took trade-offs between, this is going to take more disk space, but we want it to run faster because there's less for it to do. It doesn't have to decompress anything. So that's what they meant by optimization. They took advantage of the kernel, the dev libraries, the development libraries, and also the compilers to be able to create optimized code that ran as fast as the platform would allow. The other thing they looked at was a stateless machine. If you look at other distributions, you'll see things like the diagram on the left. Instead of organizing things like, your user data, your operating system files, your libraries, your custom configuration into well-placed locations on the file system, no, you scatter them. And in Linux, I hate to tell you this, but in the Linux distros today, a lot of these things are scattered all over the place with no rhyme or reason for why it's where being stored where it is. Do you always find system libraries in /lib that belong to the operating system? Do you always find user libraries that are in user lib? No. Sometimes you find them in share, sometimes in user local, sometimes in opt. I mean, so Intel's kind of they said, whoa, we need to fix this because the problem is that what if I do something wrong? What if I install a package that's bad and it corrupts my system and it causes it not to boot? What do I do? Well, as it turns out, you could boot back into maintenance mode and you can do two things. You can delete your etc directory. Yeah, you heard me right. You rm rf/etc. Everything gone. You also do the same for var. Delete everything underneath var. Now you would think, now if you don't try that on Ubuntu or Debian or Arch, don't do that. You'll end up with a system that is a wreck and you'll have to reinstall it. If you do that, it'll lay down the factory default configurations for you, resetting your system back to the way you received it when you installed. So the other thing they wanted to do was the other part of the state concept was this file separation. So there's a lot of security reasons why you want to do that. In the mess on the left, you could have executables sitting in with user data. And so the permissions on the directory may be set for the widest possible permissions instead of the narrowest in order to allow things to execute inside those directories. And you don't want that. You don't want to have execution permissions in your configuration directories. Right. So, right. And you don't want writable in your bin directories. So unless you're root, in which case, yeah, you're probably installing new software. So the updates that come down also are Delta. Now that's not anything earth-shakingly new, but it does save time in that when you received a patch update and you already have an installed system, you're not replacing everything again, only the portions of that particular update that have changed. It could be just a few files. It could be, one file, and you don't even have to download the whole thing to get it. What does it actually kind of do? So we talked a little bit about kind of a general, well, we optimize for Intel, but that doesn't really tell you the full story, does it? So the first thing is they optimize the compiler flags, as you would expect. But not only did they optimize them, they got aggressive. If you go read the manual if you want to know the details of everything they did. But you'll find that most of it is compiled with -O3. Now, typically, most of the optimization strategies I have seen have only gone to -O2. O3 is pretty aggressive. So the other thing is they ship with the latest Linux kernel, and that's no different than it is today. 6.14 is the current version that's out there. And it includes a bunch of stage performance patches that get laid on top of that. So it also leverages runtime optimizations. The kernel exposes a number of kernel variables that can be used to optimize your system. Intel took the time and they went through it and they did it for you, so you don't have to do that. The compile thing about compiling twice, that's necessary for the type of. They don't have a package manager. They actually call it a software bundle. So, yeah, there's a difference in the philosophy of how Clear Linux delivers software, and that is according to use case. So if you're a developer, you would install a development bundle, and you might look at one that is specific to the language that you're writing in. So if you're a Python developer, you'll install the software bundle for Python, or software update, or swap. D is the package utility that actually manages it. So, yeah, the bundle utility that actually manages it. So yeah, that's the way it's kind of organized. So if you're going against, you're going to this and you're going, how many bundles are there? Well, there's over 4,000. And you go, well, but Linux has over 90,000 packet. Don't count it that way, because a bundle could have hundreds of packages in it, or the equivalent anyway of hundreds. So don't compare it that way. The other thing they wanted to make sure about is that, are we laying down something that's secure? You know, Intel got burned a couple of times a few years ago. Yeah, you may recall that, yeah, they had a number of security issues that were significant. I'm not going to downplay them. They definitely were. So in this one, they're looking at they look at the NVD, which I think is the NIST vulnerability database, and in there is a list of the most current vulnerabilities that have been submitted and approved. So those are the ones they go after, and they aggressively manage those to get patches up against them as soon as possible. The other thing is they have a unified trust store. So that provides a common place for your certificates, rather than mixing them in with configuration for SSH, for example, like we do now. Yeah, some people create, like myself, they create directories underneath the Etsy SSH directory to put the certificates in. But nevertheless, they manage all the certificates on the system, not just the ones for SSH. So the packages point to one location for those certs and those security keys, so that you don't have to go hunting all over the system to find them. The third one is they use industry standard security features. So they use, the typical types of firewalls like IP tables, and they also look at SSL and SSH and OpenSSH and IPsec and VPNs and all those things. And then they were one of the first to actually do signed content update. Now today that's not a big deal, because most of the repositories do signed content updates. So that just makes sure that it is coming from the person that is authorized to release it. Now, is that foolproof? No. The other thing is, when we talk about being able to deliver only the pieces of a package you need, how do they do that? Well, they use something called the mixer tool. And the mixer tool can be used to either create a brand new install of Clear Linux. The first time you install it, the mixer tool is building out a full download for you. After that, its subsequent updates are partial files that are delivered. Only the pieces that you need to bring your system up to date. Yeah, they're emphasizing here that what we're talking about here is bundles, not packages. Packages is a totally different concept. But as you'll notice, RPM is one of the inputs into the mixer. So they're able to take it is the primary input into the mixer for packages that come externally, but it also allows customers to create not only their own custom things that they might need in Clear Linux. For example, maybe they're changing branding. Maybe they have compliance things, banners they have to display, or they have special rules that they have to follow and policies that are maintained on the system separate and have to be applied consistently. Well, the mixer tool allows them to do that. So once it goes through the mixer can produce either a Clear Linux OS image, which is what you would install, or it can create an update list, or it can create the bundle that allows you to install a group of software on your system that you didn't choose initially. So, and that tool is swapd, and that's the client-side piece that you use in order to pull this down when you need it. They also support containers. Now, this is an old slide. Docker is gone. They made the decision, they being Clear Linux developers, made the decision to drop Docker. I don't know if it's still something that will run. Maybe it will. But, Docker is not the direction today. It's Kubernetes. And so that's the centerpiece that's in there. The other one is a normal LexC, LexD type of container management. But they also have the ones on the right. There are two variants there for managing containers with a very thin virtual machine layer, and that just gives you more isolation. So if you've ever looked at Solaris and how Solaris does what they call zones, you'll notice that there's two kinds of zones that are on Solaris. One is called a root zone, and one is called a zone. The root zone means that your entire file system is inside the container, kernel, everything. So it's kind of a self-contained container, and that is hardened from the rest of the system. Whereas the regular zone is like this kind of a container where it shares the system runtime, the kernel, and maybe some libraries that are used that are external, that are read-only, but they're nonetheless still visible to the container. So yeah, and they are moving toward this virtual machine layer, and there are two choices for that today. There is Kata, Kata, which is they're replacing it with this one, which is Acorn. I think it's what it's called, is Acorn. So, and this is a thin, very, very thin module that manages the containers. What are the requirements that you need to run this thing? So, first of all, it has to support UEFI, and there are requirements for being able to. Your CPU needs to support SIMD extension 3, SIMD extension 4.1 for streaming. Yeah, I'm not sure why they have 4.1 in there, but they still do. Maybe it's a backward compatible. Basically, that means as long as your Intel processor is a second generation or newer, you should be okay. But in the past, they did compatibility checking before they would allow you to boot the live environment from. That's what you install from. So I didn't notice seeing that when I did it on the AMD. So either it's running kind of transparently or it's very quick. One of the two, I don't know, or they may have said, nah, we don't really need that. So yeah, as we said, second generation Intel Core. If you're wanting to run on Xeon, then you have E3, E5, and E7 versions there. Also, there's more information online for specifics if you want them. Also, Atom processors are supported as well. What do you need? You need a 64-bit x86 64 CPU that's compatible with that. It will not run in 32-bit, so don't even bother. It requires at least 4 gig of RAM. Now, they're talking about server. If you're running desktop, you're going to need more. And 20 gig of disk. Also, the graphics device needs OpenGL support. And the network needs to be active because a lot of the bundles are brought down during the time of install, particularly if you choose custom ones during that install. So yeah, you will need a network connection that's up and active. So the first thing that 614 offers, there's about, I think, 4,200 changes that are in 614. You might want to go look at, there's lwn.net has a pretty good list of all of the things that have changed. I'm only going to touch on the highlight ones. I'm not going to go all the way down through it. Yeah, you want to go through 4,200 changes? I don't. You can, if you're interested in them, you can go and look. It does have NT synchronization primitive drivers, and that, of course, supports gaming improvements on Linux. So that's a welcome change, although this is probably not the distro for you to do graphics, to do gaming on, because the graphic install for NVIDIA is an absolute nightmare on this platform. So yeah, just That's experience talking. I have tried several times to get that to work and not successful. And it is listed as a very difficult task by Intel. So yeah, if you want graphics support, my suggestion is make sure your graphics card is supported in the kernel, or you don't mind the performance of the Neovo drivers. So there's also read balancing support now and ButterFS for RAID 1. And there's also, this is not ButterFS necessarily, but uncached buffered I/O is now supported in this kernel, that's a welcome thing. There's also FS notified. That's a pre-process it's a pre-access file event, meaning that hey, there's something about to open this file, and it will fire a notification. You can see that would be helpful in a security context to know what was opening that file. There's also a new DMEM C group, and that is to manage the memory in a graphics processing unit. Some of the other changes is that Fuse is a file user mode driver that permits file systems to be installed without having to be supported directly by the kernel. You give up a lot in performance, but they now support IOU ring, which should help offset some of that. Also, the AMD XDNA drivers are supported now for the AMD NPU. So I could not find if it was supporting the Intel NPU, so it seems odd. I mean, this is the kernel level, right? This has nothing to do with Clear Linux, but I didn't see the NPU showing up. But maybe I was just looking in the wrong place. There's a new attribute delegation map for NFS version 4.2 plus. And basically that improves performance if you're running NFS on the same server. So if your client is on the same host as your server, you won't have to go through all the layers of NFS. There's also x86 TLB flush scaling optimizations. So before I give you my final thoughts though, let's go look at the benchmark results. So the mean of the I/O, more is better, and Intel does not do well here, but AMD did. They took first place here, and Ubuntu on Intel actually beat on the BOGO ops. So remember, I've said this before. I'll say it again. If you do well on the megabytes per second test, you generally don't do so well on the ops per second. So this is IOPS, and this is megabits per second. So they generally will reverse. That's normal. Yeah, and that's kind of what happened, except for a few outliers like Endeavor and yeah. So yeah, I'm not sure what's going on with Endeavor. It's running on the Intel box. It's running on this machine. So I would have thought it would have been up here somewhere, but Clear Linux definitely has some performance enhancements here that's helping it outperform Arch. So that's pretty clear. And then AMD is the winner here again, followed by Ubuntu and then Endeavor. And I would say that is pretty darn close. Yeah, I mean, yeah, I would say Endeavor beat Clear Linux in that test. So the number of first place finishes, I don't know if this is all that important, but 30 of them went to AMD. That's a pretty clear win on, there's 52 tests here in this one. So yeah, 30 out of 52, that's a pretty high percentage. As you can see, gives you the percentage right there. So it's over half. As far as last place finishes, we almost have a dead heat here between Endeavor and Clear Linux on Intel. So maybe it's just I don't know what's going on here, but probably ought to do some investigation to see what's happening. That is not normal. So I think probably the way to kind of sum this up is AMD did better than Intel with the platforms that I tested. I did have a test that I ran for the older 7700X with an Intel 3700, but for this test, it clobbered it clobbered all of these, but you would kind of expect that. It's a desktop CPU with a desktop GPU in it. So yeah, especially in the AI, it just, but you know what? It wasn't all that much faster. I don't know if I can. I don't have any. The problem is I don't have anything to compare it against. So it's like, oh, desktop versus laptop. Gee, which one's going to be faster? I don't think we need to run that benchmark, do we? The laptops are getting better, but they're not at a desktop level of performance. I mean, otherwise you guys would stop gaming on them and you'd start gaming more on laptops. The question of, can you run local AI workloads on a laptop? The answer is yes. At 40.26, whatever it was, that is pretty fast, actually. The fastest I've seen the 3070 go is around 70. So yeah, it's twice. I mean, obviously the 3070 is twice as fast, but how fast does it need to be? I mean, it is responding fairly quickly. And the model I'm using is not small. It is a floating point 16, and it is an 8 gig model. So, and I had to fit it within, the memory constraints of the machine. Otherwise, that would just make it slow. So yeah, if it was because it's going to swap at that point. If you run out of memory, you're just done. So anyway, that's all I had for today. I hope you enjoyed this video, and if you did, please like and subscribe. I hope to see you again real soon, and bye for now.